So someone mentioned the other day that we have some majorly big, long headings. Well, here's another one. This one's called partial fractions decomposition. And I think that this actually belongs more with chapter 2 when we were working with our rational functions and finding the vertical asymptotes and then deciding how the mic's not working for a second. I gotta fix this. We were talking about vertical asymptotes and also talking about how the horizontal asymptotes depending upon the powers and so forth, and whether we had a slant asymptote and so on. But I think that the reason the author put this in this section is because solving systems of equations, and you can use that to help us solve these particular problems. So first of all, we want to look at our first fraction. And our first fraction is a pretty big behemoth, right? And our goal for today is going to be to learn how to take that fraction and break it down into simpler fractions, a sum or a difference of some simpler fractions. So far, so good? So we want to verify they created this partial fraction, or this pair of partial fractions out of this. We want to verify that it actually works. Okay? So how would you make two smaller fractions into one larger fraction? We have to add them. If we're going to add them, we have to have a common denominator. Okay? So what would our common denominator be? Yeah, we need one of each, don't we? Okay? This one is missing an x plus 2, and this one's missing an x minus 3. So this is being multiplied by x plus 2. That way it will have a common denominator of x minus 3 times x plus 2. And this one needs to be multiplied by x minus 3. So it also gets that same common denominator. Okay? So what is our denominator if we multiply x minus 3 times x plus 2? Yep, because a negative 3x from times the plus a positive 2x is going to get us minus x. Okay, and then the last times the last is going to get us a minus 6. So it is our common denominator. So far, so good. Okay, now when I multiply 2 times the binomial x plus 2, what am I going to end up with? 2x plus 4. And when I multiply a negative 1 times x minus 3, what do I get? Negative x plus 3, because we distribute that negative 1 to both. Okay, and combining our like terms now, 2x minus x is, and 4 plus 3 over x squared minus x minus 6. So it works. So when we actually work this out later and we're trying to solve this, we could multiply them out to make sure that we got the right answer. Okay, so far so good? Okay, so that's our goal, is to take a big fraction and break it down into partial fractions. Okay, decompose it. Okay, so here we go. So we're first going to learn the rules of the game. And we're not actually going to solve each one of these. We're just going to start out by setting them up. Okay, so our rules of the game say that if we're trying to find the partial fraction decomposition, we have to factor the denominator. And then we're going to write the problems with constants over the factors. If they're repeated, we're going to include lesser powers of the factor, and if we have a quadratic denominator, the numerator has to be in linear form. Okay, so we'll worry about that in just a second. Let's start out by factoring first. When we factor x squared plus 6x plus 8, what do we get? X plus 4 and x plus 2. All right, so that is our denominator. Okay, so if we're trying to write x plus 8 over x plus 4 times x plus 2, we'll end up with something over x plus 4 and something over x plus 2. Okay, so what they want us to do is write those as constants. So a constant is nothing more than a number, right? And many of times we, let c be a constant and so on. In this particular section, we like to let our constant be capital A for the first one, and the second one will be capital B. And we're not going to solve this, we're just going to set it up. Make sure that we understand the rules of the game and how it works. So far, so good? Okay. All right, next example. Absolutely. You're good? Okay. So the next one. So now we want to write the form of the partial fraction decomposition of this one. And again, we're not going to solve it. We're just setting it up so we make sure that we understand the rules or the process. So first step, factor the denominator. What are we going to get for our denominator? Very good. Now, will x squared plus 9 factor further? No. So we're going to have two of them. Let's just rewrite this. So we'll have x for one of them and x squared plus 9 for another. Had this been a difference of squares that we could factor into x plus 3 and x minus 3, then we would have had x plus 3, and x minus 3. Does that make sense? We would need each of our factors. But this one's a sum of squares, and we're still in the real world again, so in this real number system, so we don't get to use our complex numbers. Okay, so far so good? Okay, so what goes over the x? An a, because that is linear, right? So we just put a constant on top. But now we have a quadratic here, so what do you think we're going to put on top of it? We want something linear, so b x plus c, yeah. Okay, because before we had just a linear, or we had linear in the bottom, so we put a single constant on top. Now that it's quadratic on the bottom, we're putting a linear factor on top, and something in the form of mx plus b, right, or bx plus c. It doesn't matter what variables we use, right, or what letters we use for our constants, but that is how you would set that one up. So far, so good? All right, so here comes the next one. We're not solving these yet. Okay, well, they'll be coming. So now we have 3x squared minus x plus 5 over x cubed minus 2x squared plus x. Okay, so we've got to have one of everything. So what is our greatest common factor of this cubic? X times x squared minus 2x plus 1, which can further factor into, yep. Okay. So our rules say that if I want to make this happen, my 3x squared minus x plus 5 over this x cubed minus 2x squared plus x is going to have to be something over x and something over x minus 1 squared and something else over x minus 1. In order to make that completely work, we have to have one of everything. And if we have a binomial squared, we also include just the binomial. Okay? So what would go over the x? A, some constant. But now that this is quadratic, we have to say bx plus c. And this is linear again, so we say d. Okay? So far, so good? All right, now that you know how to set them up, we're going to practice solving. Okay? So here comes the next one. So now we want to actually write out the partial fraction decomposition of this guy. So what's our first step? Factor. So how does x squared plus 6x plus 8 factor? So x plus 4, x plus 2. So what do I need from my denominators? Very good. What do I need for my numerators? A and B. All right, so now we're ready to solve this. And we want to figure out what A and B have to be. So how would you solve a fraction equals a fraction plus a fraction? I like it. Okay, so you found the shortcut. Because what he's actually doing is he's saying, wait a minute, I don't like denominators here, right? So what am I going to do to make this denominator go away? Multiply it by x plus 4 and x plus 2. But if I do that to one term, it has to go to everyone, doesn't it? X plus 4, x plus 2, x plus 4, x plus 2. So cancel, cancel, right? What cancels here? And what cancels here? And what am I left with? The numerator of our big fraction. The a with the part that it didn't have beneath it, the x plus 2, and the b with the part that it didn't have beneath it, the x plus 4. That's a lot easier to solve than a fraction equals a fraction plus a fraction, right? Okay. Now, in life, you can always choose the hard route or you can choose the easy route. Okay? And the reason that this is in this section of the book, even though it doesn't really seem like it belongs here, is because there is a harder route that actually requires what we did in 7.1 and 7.2. So do you want to take the easy route or the hard route? Easy? Okay, so if we're going to use easy route, we have to be very strategic in what numbers we choose. Because we want to eliminate, we want to get rid of A's and B's, right? We want to get rid of A to figure out what B is, and then get rid of B to figure out what A is. Make sense? Okay. So what would be a good number to choose that would eliminate A from our equation? -2. Why -2? A times 0 is 0, right? So 0 will be gone. Okay. So if we're going to be smart and strategic, we said let's let x be a -2. And when we do that, we'll have -2 plus 8 equals A times -2 plus 2 plus B times -2 plus 4. And we were strategic and smart to know that A times 0 is going to get us a 0. And away we go. 6 is going to equal a positive 2B. So what's B? Wow, we already know what B is. Something over x plus 4 and 3 over x plus 2. Halfway there. So now what should we let x be? -4. If we let x be a -4, then we'll have a good old -4 plus 8 equals A times -4 plus 2 plus B times -4 plus 4. And there's our 0. So a positive 4 equals a -2A. So what's A? And we have our partial fraction decomposition. Okay, let me show you why this is in this section. If you weren't strategic enough, what's the number you might typically try to let x be? 0. Okay, so if we let x be 0, we would get 8, 2A, and 4B. What's another number that you might let x be? 1. We would end up with 9, 3a, 5b. You see that this looks like what we did in 7.1 and 7.2, systems of two equations with two unknowns. But do you see why, if we're strategic and smart about it, we don't have to have this be in this chapter? Does that make sense? Okay, so you can go this route and pick any old random numbers that you think might be helpful, but think of how hard this would be to solve by elimination. We either have to eliminate a by multiplying through by 3 and negative 2, right? Or eliminate b by multiplying by 5 and negative 4. Or we can do the strategic route and go that way instead. Make sense? All right. So next one, let you get started. Try it out. All right, did you get 3 over x plus 3 plus a negative 2 or minus 2 over x plus 2? Now, depending on how you factored this, you may have factored this as x plus 2 and x plus 3, right? So if you have negative 2 over x plus 2 plus 3 over x plus 3, that's the same thing, isn't it? Okay? Depending on which one you wrote first will impact which one's on top, right? But the 3 should be over the x plus 3, and the negative 2 should be over x plus 2. Okay, so don't think, oh my gosh, I did it wrong, right? If you factored x plus 2 first and x plus 3 second. Make sense? B should come out as, it depends, right? Your B may have come out as 3 because it may be the x plus 3 that you had in this spot. Yes, so if these two are switched, that's perfectly fine. As long as whatever's over x plus 3 is the number 3, and whatever's over x plus 2 is the number negative 2. Okay? So don't just think, oh no, I made a mistake. You probably didn't. They're just switched, and that's okay. Make sense? All right. So the rest of the assignment is the rest of the sheet that you've got in front of you. And then tomorrow we'll talk about those quadratics and work on those. But I want you to get this down, feel comfortable and confident, and then we'll hit the quadratics. Make sense? All right.